Leph and Moo are just south of Nipple Creek in Utah. On today's geology lesson, we will discuss box canyons, alluvial fans, and riverbed sorting. So stay tuned to the end of this video to see how much geology you have learned. Hey guys, good morning. Good morning! You sound awfully excited this morning. Well, no, we're kind of tired. That was not the voice of someone who is actually tired. But listen, I have something to tell you. Happy New Year! Yeah, absolutely. That's what I was going to say. Happy New Year. Welcome to 2024. And we hope everyone watching this video is having a great year so far. We're about 12 hours into it, and we would love to hear what your plans are for the new year. What exciting adventures does everyone have in store? Leave comments below. Just let us know, because we would love to hear about you. For those of you who don't know, we are a relatively new science education channel, and sometimes we're silly, sometimes we tell really bad jokes. You take our humor for granted. Yes. Yes. Sometimes our humor is taken for granted. That's one of the fallback jokes that we tell, but we're kind of silly, but we also have an educational purpose, and we also like to share our adventures with you. So, the stars of our show are Leph and Moo, and I am their companion human. You're more than just a companion human. How am I more than just a companion human? You also make us coffee. Alright, that's true. You only care about me for my coffee making skills. But we are just south of Nipple Creek. Wait, why are you laughing at that, guys? You said nipple. Okay, I guess that is a little bit funny, although I don't know why. But we do try to be at least serious in the education and the science that we discuss on this channel. So if you enjoy quirky humor, if you enjoy great hikes in fantastic scenery like this area, close to Nipple Creek, stop it, close to Nipple Creek, Utah, then we hope that you will give us the favor of allowing us to share some science and adventure with you. Anyway, we are in this great box canyon. There is a wash through sandstone and what appears to be a clay outcropping. We're going to climb to the top of this bluff of Navajo sandstone right now. We have something really interesting to show you up at the precipice, right on the edge. What do you mean by precipice? Precipice is kind of like when you're on top of something and there is, you know, kind of like a danger of you falling off. Let's not fall off, okay, guys? I don't want to fall. I don't want to fall either. But we have a bit of a climb here. It's more of just like a scramble to get to the top of the ridge. And then we have some interesting geology to share with you on this brand new day of 2024. All right, let's get to the top. Let's go! Oh, guys, we made it to the top. Look at what we just climbed up. It's really far. Why aren't you guys breathing hard? My heart is thumping and my lungs are just working overtime. I don't understand why I'm breathing so hard and you guys seem to be, you know, just in the lap of luxury. What's up with that? Maybe we're more physically fit than you are. Oh, yeah, you know, that is a very good hypothesis. Say that again. Hypothesis. Say that with one tongue tied behind your back. Hypothesis. All right, look, let's be serious for a moment. Speaking of hypotheses or hypothesi or hypotheses, we are going, I see our car. It's way down there. Oh my gosh, we came up a long way and we climbed up something that is called an alluvial fan. We have a lot of fans. This is a different kind of fan. So an alluvial fan is something that has been, let's see, we've had weathering action taking place, which has eroded an upper layer down into the lower layers. So this is what we climbed up. Pretty steep climb, nothing super technical, but it just took a little bit of effort. But anyway, back to my point. Speaking of hypotheses, we're going to take a look at some of the rock formations and the individual rocks up here on this plateau above this canyon, and we're going to give a hypothesis. Do you guys remember what a hypothesis is? Yeah, that's when you absolutely know something is 100% factual. No, that is an inaccurate statement. So let's think about a hypothesis. Basically, what a hypothesis is when someone or a group of someones have an educated idea about a phenomenon that happens in science and nature. And so a hypothesis is set forward for other scientists to view the results, look at the data, and then give an opinion. And if, after lots of scrutiny, the hypothesis satisfies the scientific community, then it might be called a theory. And we're going to go look at that thin, crispy layer, and I want to show you how we can give a hypothesis on an ancient environment based on the shape of individual rocks that we find on that layer. You're talking a lot of scientific hocus pocus. I don't think it's hocus pocus, but we're going to give a good effort to help our viewers gain an understanding of how they can look at individual rocks and start thinking about the environment that was in this area when those rocks were laid down. Okay, it's a bit of a hike. Let's go. Oh guys, we made it to the top. We're at the precipice like we spoke about. Way over there in the distance, that's where we climbed up the poorly defined alluvial fans. Why are they poorly defined? Well, a lot of times alluvial fans fan out from the top to the bottom, and these don't spread out in a perfect fan, but still we can classify those as alluvium. Look way down there. There is our car. It's way in the distance. It is way in the distance, and we are alone, oh so lonely, on this cliff top. So let's take a look at what we discussed just a few minutes ago. We have a lot of these particular types of rock, and what can you tell me about their shape? I don't know. That's okay, I'll help you through this. Look how they are rounded. Oh yeah, they're kind of round. Yeah, they're kind of flat, oblongy, round. So we can determine, just based on the shape, we can give a hypothesis. Of course, we don't know for certain yet, but we can imagine that those rocks were shaped by a fluid. Now, there are two fluids that we know about. One is air and the other is water. And probably this rock was shaped by flowing water, probably a high energy, since it is quite rounded, probably a high energy, maybe a riverbed, maybe a shallow riverbed. So here we are at the top of this cliff, overlooking this box canyon. Whew, I stood up too fast. And the substrate that we're walking on, the ground level layer, are all of these rounded type rocks. So we can just look at the shape, and one guess that we can make, educated guess, a guesstimate, is that there used to be flowing water here. So water flowed at the top of a cliff? That doesn't make any sense. There were a couple of things that might have happened. First of all, there might have been an uplift. This layer of land might have been very far below us when the river was running, and then plate tectonics came about and caused an uplift. The other idea that may have happened was that there has been an erosional period in this section to where this was ground level with water flowing over it. But then there was an erosional period, which we're still in, and all of this surrounding landscape eroded away from where we are. So it looks like we're on a cliff now. It looks like we're high up, and we are high up, but at one time all of that land that is now far below us used to be at this level, and there was water flowing over these rocks. Okay, so there are a couple more things we should discuss. All right, the idea that these rocks are rounded gives us an indication that they were either eroded or abraded or somehow weathered into a roundish shape. Now, we've discussed the possibility that they were in a riverbed. There is also the possibility that they may have been formed by a glacier. So we can't completely rule out that possibility based just on shape. But there's something else we need to discuss. Not only can we determine something by the shape of the rock, the roundedness of the rock, but also the size of the rock. So we're looking at our measuring stick here, and we see that our sample of two rocks is about 5 centimeters. Using our measuring stick from 110 centimeters to 115 centimeters. So they're about 5 centimeters each. So knowing that they are such a small size, we can make a determination that they were probably moved a very long distance. Now, if they were rounded, caused by a fluid or caused by glacial movement, and they were large, they were of large size, like the size of a house, then we could make a hypothesis that they hadn't been moved a very long way. But in this instance, these rocks, individual rocks, are kind of small. They're at about 5 centimeters. So we can determine probably that they have been moved quite some distance from their original source. You can begin your exploration into what this landscape used to be like, just based on the shape. I love it! I do too. I think geology is fascinating, and I love it when we are able to kind of take a look at such beautiful, amazing vistas like the one we are overlooking right now, and we can begin to understand what geologic forces shaped our Earth. I'll look across the plateau here, and we can see a great example of alluvial fans across from us. Can we hike over there? You know, I would love to, but we just don't have time right now. And also, if we hiked over there, you know, we might miss our coffee break. I want coffee! I want coffee! Okay, I get the point. Let's hike down, and we'll make a cup of coffee, and let's discuss what we learned today. All right, guys, we finished our hike. Yay! Are you excited? We're excited for coffee. All right, well, we're making coffee right now, okay? We have the stove set up. We have a carefully constructed windshield behind it, and we are still in this, marvelous, beautiful area. Let's have coffee immediately. Well, it's gonna take a few minutes, all right? So let's be a little patient. But to end this video out, let's discuss what we learned. I don't remember. You don't. All right, I'm going to prompt you, and then I bet you'll remember. What was the first thing we learned? I don't remember. Okay. All right, so the first thing we discussed was box canyon. Do you remember what a box canyon is? Will you help us? Of course. So a box canyon is an area of erosional activity where either wind or water, or maybe even glacial activity will erode away a section to where we have steep cliffs surrounding us, and it's closed in on one end, but it's open like we see on the other end. All right, do you remember the second thing we learned? No. What about all your fans? I remember. Yeah, what is it? Alluvial fans. So alluvial fans are when material from like a hill or a mountain is eroded away, either due to wind or water, or maybe sometimes even just gravity. And that material spreads out in a fan-like pattern, and that's called an alluvial fan. Now, do you remember the third thing we learned? Yep. What is the third thing we learned? Riverbed sorting! Yes, absolutely. So riverbed sorting is when you can look at rocks and you can judge whether or not those rocks were formed by water, possibly in a stream bed, and you can determine an approximate distance that they traveled. So if they're big and not very rounded, then the rocks probably haven't been moved a long distance. However, if the rocks are very rounded and they're small in size, the ones we looked at today were 5 centimeters, that means probably that they have moved over a long distance. So that's our geology lesson for today. Wouldn't you say we are? Why do you have to bring that up? Just say it. I don't want to say it. Say it. All right, we're just south of Nipple Creek. Here